So in today's session, we will be discussing about what is Prolog. So yesterday in previous session, we have discussed till what is the logic programming with respect to that. Why we will be learning about propositional logic. Why we will be learning about your predicate logic. So now we'll try to apply these concepts with respect to your programming language called as Prolog. So talking about your Prolog is one important language whenever you are going to learn about your artificial intelligence. As already informed, Lisp is also one of the important programming language which everybody of you should have an idea, so that Prolog also is also one such language which is very important to learn about your AI. So Prolog is most widely used language to have been inspired by logic programming research. Yeah. So whenever you are learning your logic programming, the concept will be clear, but you need to understand it with respect to any programming language. You need to understand how a logic can be applied to your with respect to your programming, with respect to your AI. So Prolog is a declarative language which only defines what to be done. It will not specify how a procedure or how a output need to be ensured. It only relies on giving you the queries, right? So Prolog is also a computer programming language used for solving problems which involves objects and relationships between objects. Yeah, so this is something important. So we need to understand how Prolog is can be used with respect to your programming language. So as a programming language, it will basically deal with objects and some relationships between your objects. So in the previous session example, we have seen Amit likes sweets. There we have seen likes of Amit comma sweets. So it can be told as either it is true or false statement. A Boolean operation need to be via your output. Okay. So in the same manner, a Prolog program can also be seen as a relational database containing rules as well as facts. So how you will be working with your RDBMS, you will be having some set of data being stored, and you will be having some queries to retrieve your data from your tables, database tables. In the same manner, Prolog programming language can also be used as your relational databases, because here you will be having some queries being asked by the user, and that queries need to be addressed by your output as your Boolean operations. Okay, so let's see about what actually is this Prolog language in the further slides. Yeah, so as already said, Prolog is one important language in artificial intelligence. Yeah, so we basically have many programming languages, but coming to your artificial intelligence, Prolog is intended primarily as a declarative language. It will only try to give you what to be done. It will not specify how this can be done. Okay, yeah. So in Prolog, logic is expressed as relations, also called as facts and rules. So we need to keep in our mind that whenever I am talking about your Prolog language, it's about some basic facts and set of rules. We call them as relationship between the objects, right? Yeah. So the core of your Prolog lies in the logic being applied. So how a logic is being applied, that is one important thing about your Prolog. Because if the logic is not properly specified, so definitely the output might not be properly desired. Okay. Yeah. So the formulation or computation is carried out by running a query over these relations. So let's see how a query can be asked with respect to your given output. Suppose in the previous session example, we have seen likes of Amit comma sweets. If I say a question mark over there, so I'm asking like whether Amit likes sweets or not. The output can be either true or false. That is how we need to query things with respect to your programming language. Okay. Yeah. So let's see about what actually the structure of this logic programming with respect to your Prolog. Okay. So basically program consists of some procedures. So what actually is a procedure? Procedure consists of clauses. Like, so it is a sequence of things like a program consists of some procedures. Procedure consists of classes. Clauses are statements about what is true about a given problem. So basically we will be having some set of premises being given, and we will be asking to draw some conclusion. So here it is called as your a problem. So instead of instructing how to complete that solution, it will try to go sequentially or randomly some things will be taken and conclusion can be drawn. So these all things can be represented with your Prolog using your procedures and clauses. Okay, so each clause is called as a fact or a rule. Okay, so whenever I talk about classes with respect to your Prolog, it can be a fact or it can be a rule. The same thing, a fact, or we call it as an axiom also previously. Okay, so programs are executed by posing queries. So if as a computer science engineer, if you want to install your Prolog language, it's a single step process. We can install Prolog directly in a system, and you can start giving some queries to your Prolog, and it will try to give you answers with respect to your Boolean operations, whether true or false. But before that, we need to feed some data or give some set of rules or facts to your language. Then only it will be acting as your database, and whenever you are giving some query, it will be giving you some output. Okay, yeah. So the Prolog system uses the clauses to work out how to accomplish the solution by search through the space of possible solutions. That's what, guys. So you are here, you are going to give you some inputs in your space. From that space, what are the inputs you are given, the Prolog language will be trying to understand the given input of data, and whenever a query is being asked, it will try to search through the complete space, and it will try to give a solution according to the query being asked. So the inputs whatever you are going to specify need to be properly given, then only the output will be the desirable one. Okay, yeah. So talking about your Prolog language with respect to computer programming, it will consist of declaring some facts about objects and their relationships. So there will be relationship between objects and facts. Like as I said previously, if I am giving some sentences, you need to identify what is the predicate and what are the arguments. Similarly, it also consists of some declaring some set of rules about objects and their relationships. So the relationship can be with respect to the facts or with respect to the rules also. So asking questions or queries about objects and their relationships. So whenever I'm talking about some Prolog programming language, you need to give these three things in your mind. It actually deals with some facts, it deals with some rules, it deals with some posing some queries or asking some questions. Okay, so you all need to keep these 3 points in your mind whenever we are discussing about your Prolog language. The terminology is the same thing what we will discuss in the further sessions. Okay, yeah. So talking about your Prolog, about your facts and rules, Prolog facts are expressed in definite pattern. So let's try to see what is the definite pattern in the upcoming example. With respect to example, there will be some proper structure being developed. We call it as a syntax. So according to that, we will be trying to define some pattern. So facts contain entities and their relation. So I'll try to show you that. Yeah, you can see that here. So in the thing for called as format, relation of entity one, entity two, there likewise there will be a number of entities. Yeah. So every fact or rule ends with a dot. So a typical Prolog fact goes as follows. Yeah. So here you can see the format or the syntax according to how a fact or a relation can be defined. So for example, I can say friends of Raju, Mahesh. Here, friends is the predicate, and Raju and Mahesh are the two different persons. So, the relationship between them we need to identify using the given predicate. So, it can be said that Raju and Mahesh are friends. That's what is my understanding from the given syntax. Here, you can see singer of Sonu, or we call it as singer is the verb here, or you can say like it's indicating the role of some person called as Sonu. So it is stating that Sonu is a singer. And you can see in the third statement odd number of 5. That is 5 is an odd number. So this is the input what I am trying to give to my database with respect to my Prolog language. Yeah. So talking about this, entities are written within the parentheses separated by comma. So here you can see entities are written within the parentheses separated by your comma. So here you can say Raju, comma Mahesh are called as your entities, and friends is the relation between them. Okay, yeah. The relation is expressed at the start and outside of the parentheses. So here you can see relation can be expressed at the start or end of your parentheses. That is, uh, entities will be as part of your inside your parentheses, and outside your parentheses you will be having your relation. Okay, yeah. So I hope these statements are clear with you guys. So whenever we talk about your Prolog has some running queries. As we are discussing since long time, like we will be having some set of queries. So here we can see some input here in these 3 lines example. You can see friends of Raju comma Mahesh is one premise or one condition what I have specified. Singer of Sonu is one important input what I have specified. Odd number of 5. These 3 statements or these 3 propositions I have given as my input to my Prolog language. Now I'll try to give some queries and see how a solution can be designed. Okay, yeah. So a typical Prolog query can be asked like this, like query 1. So it is asking like question mark hyphen singer of Sonu. So when I say question mark hyphen, it indicates a query here. So the output is said as S because according to the input whatever we have given here, singer of Sonu, which means Sonu is a singer. The query is asked that whether a Sonu is singer or not. Yeah, so definitely answer is given as yes. So according to the given data, as per the knowledge base, we call it as the knowledge base. It contains the above fact. So the output was given as S. If there is Sono is not a singer, the output would be given as no. You can see the same thing in your query 2. So question mark, that is query is asking like odd number 7. So there is no input about odd number 7 here. Here it is given as odd number of 5. That is being given as the knowledge base to my machine, to my intelligent machine. So the output is given as no, because even though odd number, so this is the difference between a human interface, a human being, and your propositional logic. That's why we are coming for your predicate logic. So basically 7 is a odd number according to our knowledge, but according to the knowledge base of your given system, 7 is not fed to your knowledge base. So the answer is given as no. As our knowledge base does not contain the fact above fact, so output was given as no. So you need to train your model or your algorithm properly with a good knowledge base. Then only the queries can be answered yes or no according to the given question. There should not be any contradictory statements. There should be a proper knowledge base. Then only these running queries can be asked, and output also can be designed in the same manner. Okay, yeah. So with this I hope everybody has understood what actually is the scenario behind your Prolog. So we are not actually much discussing about Prolog programming language. We are just having a glimpse on how a Prolog language can be used as part of your artificial intelligence with respect to your logic programming. So with this, we'll be trying to understand what actually is your Prolog language, how this is being used in your artificial intelligence, and what are the basic things with respect to your Prolog language. So here we are having some facts, some rules, and also we are having some queries. So we need to predefinedly give some knowledge base with respect to knowledge, facts and rules. So according to that, whenever queries are being asked, we'll be getting some answers according to the knowledge base whatever you are providing. Okay, yeah. So now let's quickly see about what are the advantages and disadvantages with respect to your Prolog programming language. So Prolog programming is easy to build database. It doesn't need a lot of programming knowledge. It only needs a minimum programming language from your side. Okay, so we can say Prolog language is not so difficult to learn. It is very simple to learn because from the given inputs, you need to build a knowledge base, and you can ask queries accordingly, and you'll be getting your desired output. And matching, pattern matching is easy because the queries whatever you're going to define, you'll be define what is the predicate, what are the arguments. The searching mechanism also is a bit easy here. Search is recursion based, that is a continuously looping element. So Next advantage is it has built-in list handling. That is, it makes easier to play with any algorithm involving list. So because everything is arranged in a manner of list, it is very easy to understand about how everything is stored as part of your list. So these are some of the advantages of your Prolog programming language. And now let's talk about what are the disadvantages of this Prolog language. Yeah. So Prolog language, when compared with Lisp programming language, as I said in the earlier sessions, Lisp also is one of the important programming language with respect to your artificial intelligence. So Lisp dominates over Prolog with respect to input output features. So comparatively Lisp and Prolog, Lisp is a far better language when compared with your Prolog language for your logic programming. Okay, yeah. Sometimes input and output is not easy. That is, defining a good knowledge base and getting the exact desired output is not so easy with respect to your Prolog language. So these two are termed as the disadvantages of your Prolog language. So as I said, it has applications with respect to artificial intelligence. It has applications with respect to natural language processing. Prolog is highly used in AI. Prolog is also used for pattern matching. So from the given knowledge base over natural language parse trees. So these concepts, Prolog can be also be used as part of your natural language processing. That is where searching mechanisms can be done and pattern matching can be done easily with respect to the given inputs. Okay, yeah. So we can understand about this predicate logic and also the Prolog language with respect to some small example again here. So this is a procedure, we call this complete as a procedure. And as I said, Prolog language consists of some procedures, clauses and statements, also facts and rules. So this is your complete thing called as your procedures. So here we are taking a predicate called as your elephant. So elephant George. That is, there is some relationship between elephant and George. Whether George might be owner of that elephant or Mary might be owner of that elephant. So now we are trying to specify some rule here. So this is very important here, guys. What is a rule with respect to your logic programming? So with respect to your Prolog. So we have seen about facts, we have seen about procedure, clause. Now we are trying to see what actually is rule here. So we are here we are speaking about what is a rule. So elephant of X. So this symbol indicates your here you can see some colon and hyphen indicates your if condition. That is if then rules. That is when something is called as elephant if it is in gray in color. So here X can be color or it can be anything. So the meaning of this rule is specifying that something is called as elephant. This symbol indicates your if it is gray in color, comma, it is a mammal and it has a trunk. So I think everybody can accept this thing because elephant basically the color of elephant is gray in color and it is a map whether it is a huge element or it is a mammal. So it all depends on the queries what you're going to ask. So definitely it has a huge trunk. So now let's try to see about that. So now I am going to ask a query. The query is like question mark elephant of George. So according to the knowledge base here, George and elephant are having some relation. Okay, 1 second. Okay, so we are going to take a small example for your understanding your logic programming with respect to some procedures. So I have considered a predicate here called as elephant. Now I am having some set of statements with respect to some elephant. So the elephant. So here we are representing this with respect to some procedure. But before this procedure is being defined, we are going to have some statements like George is the owner of elephant. Mary is the wife of George and she's also owner of elephant. Likewise, we'll be having some set of statements and we have converted those statements into some clauses or we call it as facts. So now these all facts have been defined and now we are going to define a rule to specify about some elephant. So I'm saying that elephant of X, X indicates anything here, X is not predefined here. Now this is your symbol, that is colon hyphen, indicates if condition with respect to your Prolog language. So here I am saying that something is called as elephant if it is gray in color. So here gray indicates color of your elephant. Mammal is the type of animal, whether it is a mammal or it is different type of animal. So whether it has a trunk or not. So I am specifying that something is called as elephant if it has these features. Okay, so now, yeah, now I am trying to post some query specifying that elephant of George. So this is the knowledge base, that procedure whatever you are having here is your knowledge base which is being defined to your language. This is the knowledge which it is having now. According to that, whenever you are having some question or a query, it is specifying that whether output is yes or no. So here again it is saying that elephant of Jane. So Jane is nobody here, right? So we are having only input as George and Mary. Jane is not as part of our knowledge base. That's why it is being defined as no. Okay, yeah. So I hope this is clear now, guys, about what actually what are we discussing. So let's again talk in depth about why we should define some rules with respect to this logic programming. So a rule is an extension of fact with added conditions that have to be specified for it to be true. So that's what we have done here. A rule is being specified here with respect to your elephant sentence here. A rule is being specified like it is an extension of a fact. So here you are having some facts. These facts are being extended as part of your rule with some added conditions. So we are specifying some conditions that have to be specified for it to be either true or false. So if you want to say whether it is a true or false, you need to specify your rule properly. Okay, a rule is much more compact than a fact list of facts. Yeah, so because a rule specifies everything, it is a bit compact than as part of your list of facts. So where facts depend on a group of other facts, because facts here you can see there is one fact called as elephant of George, other fact like elephant of Mary. So there can be a number of relationship between your facts. As I said, the initial things, facts have some relationships, objects have some relationship among them, rules also have some relationship among them. Okay, yeah. So here you can see one sort of example to understand about what actually is a rule here. So here we are having an example stating that John likes all people who likes sweets. That is the given statements. So whoever it might be a male or female, whoever it may be, any people, if they like sweets, John will like them. So now we are writing some separate facts with the given statement. So here only one statement is given, but basically we have some set of given statements, and from that set of given statements we need to specify some facts. So it is saying that likes of James comma sweets, but James is not a person here. So whenever that is fed to your database, it will be saying no. Like John comma James is one more what do you call fact what I am defining. Likewise, we need to define some set of rules. So yeah, here you can see one more statement. John likes any object provided it is a person. So in Prolog, as I said in the previous example, a rule is something like this: likes of John comma X. Here likes is your predicate, John comma X are your arguments. As I said, this symbol is indicating your if condition. And again I am saying that like of X comma sweets is your body. It can extend to many ways. So you need to understand about how to define a given statements as part of your set of rules. Okay, so yeah, we are not concerned about in-depth concepts of Prolog. So we need to basically have an idea about the structure of how a rule is being asked as part of your Prolog language. Okay, yeah. So let's see one more example with respect to understanding your Prolog language. So to write a rule, X is a sister of Y. So this is a given statement. I want to write this as part of my rule. So X is a female because X is a sister of Y. So we are not specifying about Y whether it is a male or female, but I am giving that X is a female. So X has a mother M and father F because is having some sister. Definitely they have some parents. X has a mother called as M and father F, and Y has the same mother and father as X because they both are sisters and brothers, or brother and both are not sisters, so the parent might be same. So now I am trying to write a rule with respect to the given statements according to your Prolog language, that is sister of X comma Y if father of X comma parents are X M, parents of uh, X is like the female one here, M comma F, that is again parents of Y comma M comma F. This complete statement we can write into single statement. Yeah, 1 second. I'll just try to make this into one single statement and for your understanding. Okay, I hope now you'll be clear with these things. Yeah. So these all things are single statements. It's talking about a rule here. So when I want to specify whether X is a sister of Y or not, I need to define a rule which is having some sort of inputs like this. That is sister of X comma Y if female of X, that is if X is a female, and M and F are the parents of X, and M and F are the parents of Y, then only these two are called as sisters or brothers, or brother and sister. So here, because we are not known about Y whether it is a female or male, we are calling it as sister of X comma Y, that is X is a sister of Y. Okay, so I hope this thing is clear, like how to define a rule from a given set of premises or given set of statements. Okay, yeah. So to define a rule, again one more example here, guys. So to define a rule, X is a grandfather of Y, comma if X is a father of Z and Z is a parent of Y. So basically these 10 statements will be given as part of aptitude questions in your higher classes whenever you are going for your placements. So at that time, if you want to specify like the proper reasoning can be given to the given premises. The same manner, the proper reasoning can be given as part of your programming language using your logic programming convention. So now the above statement, X is a grandfather of Y. So X is a grandfather of Y. That is, Y is a smaller one. If X is a father of Z and Z is a parent of Y. So now I am trying to define this complete statement as part of my rule. So it is stating that grandfather of X comma Y, that is Y is a grandfather of X, sorry, X is a grandfather of Y if father of X comma Z, that is X is a father of Z and Z is a parent of Y. The same thing is represented with respect to some rules, rule as part of your Prolog language. Okay, so even in examination point of view, whenever you are being asked about Prolog language, you might be asked about some sort of questions, and you will be asked to develop some rules according to the given premises or the given statements. Okay, yeah. So next statement you can see, X is a sibling of Y if they both have the same parent. That's a valid statement according to the English language. That is, X is a sibling of Y if they have the same parent. So that can be represented like sibling of X comma Y if we are only doing as if condition here. Parent of Z comma X comma parent of Z comma Y. So here parent is Z and X comma Y are your children. That is very simple rule what we can define. So this is about how we can define some rules with respect to your Prolog language. Okay, so this is something new for us, let's try to quickly recall about what we have seen about till now about your logical programming. So we are going to define a procedure from the given premises. A procedure consists of some facts and clauses, and from those facts we need to define some rules. And later we'll be asking some queries that can be given yes or no, some boolean operations on the knowledge base. Okay, so why we should go for rules, how a rule can be specified, what is the if condition need to specify, these all things are being covered as part of today's session. Okay, yeah. So now whenever we are talking about some queries, so how queries can be asked and how we are getting some replies, there are two different types of queries as part of your Prolog language. One is ground query, other one is non-ground query. So let's try to understand what actually is this thing. So in a ground query, the goals contain constants. So as already said, we have learned about what is a constant and what is a variable. So answer to the ground query is either yes or no. So here you can see the statement, this can be called as your ground query. The answer can be your yes or no. It cannot be either it can be either of the both, depending upon whether it is a logical sequence or of a logic program or not. So in non-ground query, the goal should have at least one variable as an assignment. So without a variable, there cannot be a non-grounded query. So coming to your ground query, it gives the statement as yes or no. So this is the difference you need to have. So whenever you are having at least one argument as part of your given predicate or procedure, then it is called as your non-ground query. Okay, yeah, here you can see the example about what is a ground query and what is a non-ground query. So here you are having a statement, is Raman a grandfather of Manu? That is the question I want to ask to my system, to my intelligent machine with respect to your Prolog language. So I am saying that question mark hyphen grandfather of Raman comma Manu. So here we are not having any arguments. Grandfather is a relationship or the relation between Raman and Manu. So that is the predicate. Grandfather here is a predicate or the relation which is being specified between two persons. This is called as your ground query. Here we are not concerned about your variable arguments. Coming about your non-ground query, does there exist X such that X is a father of Manu? That is, I'm asking a question, who is the father of Manu? Question mark here like hyphen, question mark hyphen, father of X comma Robert. Here we are having one argument or one variable. That's why it is called as your non-grounded query. Okay. Yeah. So coming to your last part of your Prolog language, that is, what are your conjunctive queries? So basically, you'll be having an answer like yes or no for your given question. And sometimes in non-grounded queries, the answer need to be specified like what is your variable here. So here I am asking a query like, is Raman father of Robot and Robot is a father of Mike? So that question, that query can be framed as part of rules like question mark hyphen father of Raman comma Robot comma father of Robert comma Mike, because there are different arguments here or different persons. The relationship father is not changed, but the people are changing here. So the answer is yes here. That is Raman father of Robert and Robert is the father of Mike? Yeah. So in non-grounded query, that is question mark hyphen father Raman comma X, because robot is the same person in the both the scenarios. We are treating it as X, and we are trying to proclaim the same in the next thing like father of X comma Mike. So here X is called as your robot. So whenever you are having some sort of like these things are called as your conjunctive queries. Okay. Yeah. So that's it guys about your Prolog language.